Hello, I'm Samya, and today I'll be presenting our work on breaking down the invisible wall of informal fallacies in online discussions. This work was done with my co-authors Vanabala Lau and Roxana Horinkar. So what is an argument? An argument consists of three parts. The first is a proposition, also called a claim, conclusion, or a standpoint that needs to be validated. For example, the claim is in this case that vaccine B should be avoided. The next part is the premises, which are the backing propositions. Here, the premise is vaccine B has not undergone clinical trials. The final part is an inference relationship between the premise and the claim. Here, because vaccine B has not undergone clinical trials and hence vaccine B should be avoided, there is an implication. And this whole construct together is called an argument. A fallacy is an incorrect argument where this premise does not support the claim. Let us revisit the example that we just saw, where the claim was vaccine B should be avoided, and the premise that people in the Stone Age did not take vaccines. This premise is factually correct, and it is true that people in the Stone Age did not take vaccine, but then this does not validate or invalidate the claim that vaccine B should be avoided today. And therefore, this whole construct is a fallacious argument. So in order to detect the fallacy, the content and context needs to be analyzed. So here we would look at the premise closely, where there is a reference to people in the Stone Age, and there is an implicit assumption by the argumenter that because something is natural, it is correct, and this is an appeal to nature fallacy. So why study fallacies at all? Argumentation and therefore fallacies, they appear in our day-to-day discourse, and understanding fallacies really strengthens how we reason about the events around us. And this is especially important in today's times when polarization and propaganda is really common in our society. So this is an outline of our methodology. The first thing that we do is we want to identify the types of fallacies that are pertinent in online discussions. The next is to create an annotated data set. So there are two steps when we are trying to create an annotated data set. The first is to gather data using noisy labels and then clean this data by crowdsourcing. And the last step is to detect fallacies, which has two aspects to it. The first is the classification part, where we want to classify the whole argument if it contains a fallacy or not, and if it does, then what kind of fallacy. And the next is to identify the span of the fallacy, that where in this argument exactly is the fallacy occurring, where is the faulty premise. Reddit is a very popular online platform for debate and discussion, and we use the content of Reddit for our study on fallacies. So Reddit had about 1.7 billion comments posted on it in the year 2019, and over 100K comments had the word fallacy mentioned in them. And the question is that is there some way in which we could gather annotated fallacies by using these fallacy word mentions? But before we go that, we need to kind of see what fallacies we want to study in this work. We choose fallacies based on two major criteria. The first is the frequency. We want to keep the fallacies with the most mentions on Reddit because these fallacies are likely to be more popular in the online social platform. And the next is ease of annotation. We want the fallacy to be easily and identifiable by a crowd worker because our task is designed to use their help. So keeping these in mind, we come up with this list of 8 fallacies that we have considered in our work. So moving on to the data gathering step, what you see here is is a discussion structure on Reddit. We have a submission title. There are comments, and each comment has a child comment, which are responses to the parent comment. And the comment in the red box is interesting because it has the word fallacy mentioned, and it says that there is fallacy of relative privation, which is happening in the green box, maybe. And because this red box is labeling a potential fallacy in the green box, we are saying that, okay, this is what we call a label comment. And the parent comment of it, which we also call comment of interest, is a likely candidate for a fallacious argument. So once we gather data, we move on to the part where we use the help of crowd workers to clean this data. The first question that we ask them is this label correct? Is the fallacy mentioned actually true? Does comment of interest really contain a fallacy or not? If they respond with a yes, then we ask them to highlight the part within the comment of interest that is fallacious. And this way we can collect our annotated dataset. The dataset that we collected had about 3.3K comments, out of which 1.7K were truly fallacious. Each fallacy has about 200 samples, and the average inter-annotator agreement is about 0.51. We got the best agreement on appeal to authority fallacy and least on hasty generalization. So the annotated dataset that we had so far was equally split between fallacious and non-fallacious comments. And we thought it made sense to add more negative examples as that can be helpful for a classifier to better learn the language pattern rather than just picking on the topics or certain words in the comment of interest. So to do that, we looked at the annotated dataset that we had, which was cleaned by our crowd workers. Here we looked for users that had correctly labeled the comment of interest. So when they said that there is a fallacy occurring, it was indeed marked correct by the crowd worker. And we made a list of these users, which we call, say, users X, and they know at time D, which is the time of their comment, that what a fallacy really is. And once we knew that at what time a user knew about a fallacy, what we could do is find the comments that they made after that time, and in case they contain the word fallacy or not. And the rationale is simple, that in case a user knows about a fallacy at time t, then in the future, if they see a fallacy occurring, it is likely that they will probably mark it again. And in case they're not doing that, then probably it's a non-fallacious argument or discussion. So by doing this, we added another 6.4K comments to our annotated data set, and together we call them the full data set. So the next step was to actually start detecting these fallacies. We used two kinds of architecture. One is word-based, and the other is multi-granularity architecture. The multi-granularity architecture has been shown to perform well on identification of propaganda, and we therefore explored it in fallacy detection as well. We performed two tasks. The first is comment level prediction, where we are classifying the type of fallacy. So for example, if the comment of interest says avoid vaccines as people in Stone Age did not take vaccine, then we wanted this whole sentence to be labeled as appeal to nature. The next is token level prediction, which is more of a sequence labeling task, where we want to identify the span of the fallacy. So what I mean by that is avoid vaccine as people in the Stone Age did not take vaccine. The part that people in the Stone Age did not vaccines is forming the faulty premise, which is not really validating the claim, and we want this identified. So here, what you can see on the left side is the general structure of a discussion that we have used. We have designed our data collection in such a way that each comment of interest has one parent, and of course, there is a title of the submission. So in order to do this classification or sequence labeling, we firstly just look at the comment of interest. And that is what we mean by when we say on the right side, bird or MGN. We are just looking at the comment of interest and trying to see if we can identify its label correctly, which is what fallacy it is, and what is the span of the fallacy in the comment of interest. Then we can also add more context, and this can be in the form of the parent or the title. And that is what we mean by when we say BERT T, which means BERT title, or BERT P, BERT parent, and so on and so forth. And how we do it is we just concatenate the comment of interest with the parent comment or the title and see if the classifier is performing better. And we indeed find that adding some context is improving the fallacy detection. So the main contributions are: we present a methodology for labeling fallacies in online discussions and use this methodology to create an annotated corpus of frequent fallacies on Reddit. And we investigate methods to identify fallacies. And we conclude that adding context is helpful. The data and code for our work is available at the shown link. Thank you.